In this example, we look to take that TextShapes example previously and reconfigure it a little bit, refactor some of the code to demonstrate some of the other principles of object-oriented programming and inheritance. From the diagram here, you can see that line and FancyLine are related by inheritance, but composition is used in all other cases. So that's indicated by these red dashed arrows here. Also, you'll notice that the classes have these hashed out thin red lines through them. That's the case when the file needs to be updated. We've made some source changes here to our original TextShapes example to make TextShapes 2, and now I need to recompile it to update the info. So from this UML diagram, I can simply recompile the source code, and it's recompiled cleanly, and now the boxes are clear. So let's do a review of TextShapes 2 and see what's changed from our original implementation. Starting out again, we start with class point, and point is a Cartesian coordinate, XY coordinate system. Each object has an X and Y location, and we have a constructor here that initializes a point from two integers. We've made a second constructor here. It's called a copy constructor because it takes an argument of itself, a point argument, to create a new point. And in order to create the point, this is called overloading. Whenever a method of the same name but a different parameter list is created, that's called an overloaded method. So we've overloaded the constructor point. This one has two ints in its parameter list. This one has a single point in its parameter list. Now, we could re-implement the code similarly to take the point's X data and assign it to this object's X data and do the same with the Y data. But there's another way of invoking a constructor within the same class. The keyword this is used to reference the target object. And if we use the keyword this as a function call, we'll call the constructor on our same class. So the one argument point constructor here that takes a point is going to call the previous constructor up above using the this method. So we simply pass it two ints. P.x is the formal parameter's x coordinate, and P.y is the formal parameter's y coordinate, and those are simply passed to the constructor above on line 12. This kind of piggybacking behavior is good on overloaded constructors, as well as methods like toString, where we can invoke the same functionality in our parent class using inheritance. Rounding out the point class, we have our toString method here on line 25, which is the same as before. So this just implements a new kind of constructor called a copy constructor, and it's useful when you wish to make a copy of an object and perhaps change some of its properties or do other things with it without changing your original object. Scrolling down a little bit, now let's see what the changes are to class line. Class line no longer relates to the point class with inheritance, but rather composition. And so we have two explicit points to a line, a start point and an end point, and they both are there by composition. So our line constructor that takes four integer objects is a little bit different. We simply create 2 points with the x and y data and assign them to start point and end point. We also add another line constructor that takes 2 point objects. This is overloading as well, because the parameter list differs between the constructor on line 36 that takes 4 ints and the constructor on line 42 that takes 2 points. The body of the code is very straightforward. Just take the first object and assign it to the first instance object, starting point, and the second formal parameter, P2 point object, and assign it to the endpoint. The toString method here now simply uses the toString method from class point to announce that the line starts from its origin to its endpoint. Now FancyLine still uses inheritance, and that's important because with a fancy line, it is a kind of line. When we talk about using inheritance, this relationship is often referred to as an is-a relationship. In other words, a fancy line is a line. Now, the composition relationships shown by the red arrows here are often referred to as a has-a relationship. So a line has a point. In fact, it has 2 points. A circle has a point. A cylinder has a circle. So composition is often called the has-a relationship, and inheritance is often called the is-a relationship, and that is the distinguishing factor that tells you when you use one form over the other, when to use composition versus when to use inheritance. We continue to use inheritance here with FancyLine. It extends class line, so that's its base class. So it has a line subobject, and we also add a width and a draw type just as before. Its constructor now is overloaded. We have the first constructor which we had previously, which took 4 ints, then the width and the draw type, and used the constructor on class line to build that line subobject here on line 60, and then initialize the width and the draw type from the 2 additional formal parameters coming into the constructor. That's one FancyLine constructor. We can also use and overload this with another constructor that takes 2 points, point 1, P1 and P2, and a width and a draw type. And in this case, we invoke a different constructor on our parent class line, passing the 2 points, and then initialize the width and the draw type. So overloading is a commonly used practice with object-oriented programming. Now, overloading is different from overriding, and overriding is simply redefining a method you've inherited. FancyLine extends class line. Class line has a toString behavior right up here on line 48 that we're going to override. To override a method is to redefine it, and on line 72 we're going to define and override the inherited toString method from line with our own toString method for FancyLine. Now, in this overriding method, we can still invoke the method on our parent using the super object. So when a FancyLine is going to represent itself as a string, we first output the draw type, which is a string containing solid, dash, dotted, etc. And then we tell the line subobject we have here by inheritance to represent itself as a string, and then we tack on the width, and that's how we describe a FancyLine. So don't confuse overloading, which is shown here with the constructor, with overriding, and overriding is being demonstrated by the toString method. In our previous example where we had point line and FancyLine all related by inheritance, back on this diagram here, we were overriding the toString in line and in FancyLine. So overriding and overloading are 2 common practices used with object-oriented programming. Class circle is essentially unchanged from before. It has a center point and a radius, a constructor, a get area, and a toString method. And class cylinder is essentially unchanged from before. It uses composition to have a circle at its base and its height. It also has a simple circle constructor and a get volume method that uses the get area method from its associated class circle to determine its volume, and a toString method that's also unchanged from before. So let's test all this now. Here we have our main method, which is going to create a new point, and we'll output that at the origin. And then we'll create another point in order to call both line constructors. We need 2 points, and then we can call the 4-argument line constructor to create line 1. And then we can call the 2-argument line constructor to create another line testing both constructors. We'll then print both of those out. After that's done, we'll create another FancyLine object. I'm only calling one of the constructors here, though. I'll leave it to you to create another FancyLine using its other constructor. And we'll print that out and then finish off by creating a circle and a cylinder and output those as well. So we've recompiled the code. I'll go ahead and run it. And we get the identical output from before, which is what we would expect. So it passes our test, and we've demonstrated another way of using composition and inheritance to achieve our goal with these simple text-based shapes.